Okay, good people. What we're going to do is we're going to talk about your volume control and your tone control on your guitar today. And the reason we're going to talk through that is because it helps me to talk about a number of things that are going to help us to build a tube preamp. So, number one, what exactly is a preamp? Well, a preamp has two purposes. Number one, a preamp um, allows you to make your guitar louder, right? Or make your bass louder. Now, one of the things to note is that in an amplifier circuit, the big tubes or the power tubes that we use in order to drive your bass or your guitar signal through a speaker require your signal from your guitar or bass to be a certain level of loudness before it can actually push that signal through your speaker. So it's the preamp's job to get your signal up to the point where your power tubes can actually take your guitar signal and amplify it to be loud enough through a speaker. So that's one purpose of a preamp, to just get your signal up to almost line level. So another purpose of your preamp is to allow you to shape the tone of your bass or your electric guitar. So that may be allowing you to drop off some of the treble, which are the higher notes at a higher frequency, or to add some treble, or to drop off some of your bass and add some of your bass. And as you know, if you take your Telecaster guitar, you typically will have controls for volume and for tone. So we're going to talk about how those work. We're also going to talk about the role of a few different components that you'll have in your volume and tone circuit in your guitar, which are resistors and capacitors, and I'll talk about their role within your volume and tone circuit for your guitar and your amp. But first, what we're going to do is we're going to start to talk about resistors. Resistors are a very important component because resistors, what they do is they resist the flow of electric signal. So what our pickups and our guitar and basses do, they turn the movement of our strings into an electric signal. And what resistors do is that they slow down the progress of that electric current. And the way that they do it is by providing friction on that electrical current. So if you take a look at the symbol that we have for a resistor here, if you compare this to a straight line, let me just draw a straight line right quick. We know that the shortest path is between 2 points is going to be a straight line. If you take a look at the symbol for a resistor, you can see that that path is very jagged, right? So the purpose of a resistor is to slow down electrical current, which makes your signal quieter, okay? So if you get a resistor, and I'm going to show you what a few resistors look like. Resistors are measured in a number or a unit called ohms. And the larger the resistor, the more quiet it's going to make your signal. Okay. So if you get a resistor that has a certain value, it's going to drop your volume by a certain amount. Okay, so a resistor is a resistor at a set value is always going to drop your volume by a set amount. We're going to come back to formulas later to allow you to calculate how much your volume is going to be dropped by a certain resistor. Let's take a look at a resistor now just to see what they look like. So here are a few resistors. They have two leads or ends where they can be a part of your volume or tone circuit. These resistors all have different purposes, which is why they kind of have different shapes. This is a metal film resistor. The outside of it is metal, and it has some material on the inside that slows down your electrical signal. Okay, so this is what they look like out in the wild. Now, the reason I'm starting to show you symbols is every circuit, so this is a volume or a tone circuit or any circuit that you'll come across, can be described with symbols. And when those symbols are put together to describe a circuit, they're called a schematic. And understanding a schematic is key for you to be able to build something. It's almost kind of like looking at the blueprints for a building that an architect would make. So electrical engineers create schematics rather than drawing blueprints, okay? So this is going to be the symbol that you'll see most often for a resistor. So now that you see what that symbol looks like, we're going to go back one step. To what I said. The purpose of a resistor is to slow down the passage of electrical current. So the volume of an electrical signal, such as one coming from a guitar, is measured in a quantity called volts. Okay? So what we know is that if a signal passes through a resistor, it is going to cause a drop in voltage. Okay, which means that it's going to cause a drop in volume. So if we have a resistor, let's say that measures at 10 ohms, it's going to drop your volume by a fixed amount. Now, one of the things that would be cool is if we had a resistor that we could actually change the value of, right, by, let's say, turning a knob or moving something. Then we could have a volume control. And that is exactly what a potentiometer is called. So a potentiometer is a resistor that you can change the value of just by twisting a knob. And I'm going to show you what that looks like out in the wild. And then I'm going to show you what the symbol of a resistor, a potentiometer, looks like in a schematic. So this is a potentiometer. Most knobs that you have on something that's electrical in nature, you're going to have a potentiometer underneath it. Okay. And that you're typically going to have a little knob on top of this, and there are going to be 3 places where you can make connections on a potentiometer. And I'm going to show you why in a quick second when we start to look at the schematic symbol for it. Okay. So I'm going to pull up actually I'm just going to copy paste it. So this is the schematic symbol for a resistor. Okay, now the reason for that, as you can see, we have one resistor here, and what we have is we have an arrow that's in the middle of a resistor. So this arrow is actually cutting this resistor in half in this particular picture. Why? Because from here to here, so we have something called the wiper, which allows you to pick how much of the resistor your signal is going to run through. Okay, so if we take a look at our physical resistor, the wiper is going to be here. Okay, and where you position that knob with your thumb is going to determine how far along this resistor your wiper is going to be. Okay, now the way that a volume control works is, again, it's going to have your signal go in through this potentiometer here and exit the potentiometer typically through where the wiper is. So as you can see, you can control how much resistance you're going to get from this potentiometer by placing the wiper somewhere. Now, let me give you a bit of a clearer explanation of what's happening. So I'm going to zoom out just a little bit here. So here we have a representation of a volume pot with the wiper at 3 different places. So if we have the guitar signal coming in here through the top of the potentiometer and coming out through the output, as you can see where the wiper is going through the maximum amount of that crooked path that we get from the resistor. So it's going to face the maximum amount of resistance. So in this position, we're going to get the lowest output. Okay, so here we have the wiper right in the middle of that jagged path, which means our volume is going to be at 50%. So here our volume was at 0% because our guitar is going through all of the resistance presented by our potentiometer. Okay, now Here, the wiper is in the middle of the jagged path presented by that potentiometer. So our volume is going to be at half. Okay. And here, the wiper is going to be at the very top of the potentiometer. So the signal will go through here and it wouldn't reach any of that jagged path at all. So this would make our volume be at 100%. Okay. Now, it's important to kind of talk through this because built into a potentiometer is something called a voltage divider, which is kind of a key tool that gets used in deciding guitar amplifiers to control. It could be the volume of a signal, or many times it's used to control the volume of a signal. So this is showing what happens. Now, one thing to note about a voltage divider is that you're going to have your output in between two resistors of some sort of value, and you're going to have a signal at the top and ground at the bottom. So once we get to ground, the value of the volume of your signal at ground is going to be 0 volts. Okay, let's say your guitar signal is 2 volts. Okay, in a potentiometer, what's going to happen is your signal needs to go down from 2 volts to 0 volts. And the amount that voltage drops is going to be proportional to the size of the resistor. So, for instance, if we turn the pot so that this resistor that we have up here before we get to the wiper is 250,000 ohms. So let's say we have a volume potentiometer that's 250,000 ohms. That means that our wiper is in this position where it's getting all of that crooked path. What that means is that all of the voltage is going to get dropped from here to here, being our output signal. And by the time we get here, our signal is going to be at 0 volts. Okay? Let's say we turn our potentiometer so that the wiper is in the middle of that resistance that we get from the potentiometer. So we have half of the resistance before the wiper and half of the resistance below the wiper. What that's going to mean is that half the voltage is going to get dropped before the wiper and half the voltage is going to get dropped after the wiper. Okay. So we have 120. So what it's doing is it's cutting the resistor and the potentiometer in half. Half of our voltage gets dropped. So we go from 2 volts to 1 volt here. And at our output, we'll have a volume of 1 volt. The rest of that voltage is going to get dropped over the second half of the potentiometer. Okay. And here is when we have our wiper right before it gets to that jagged path that gets presented by the potentiometer. Okay, so what that means is that the guitar is not going to go through any of the resistor at all. So since it's not going through the resistor, you're not going to have any drop in voltage or volume. Okay, so what that means is that the guitar signal is going to go through 0 ohms, or K is short for 1,000, 0 ohms or 0K of resistance. Okay, so the output is going to be a full 2 volts. So as you can see, the rest of that 2 volts gets dropped by the part of the potentiometer that's past the wiper. Okay, so this schematic that I'm presenting you is exactly how your volume circuit works in a Telecaster. So let me, I'm going to pull up a wiring diagram of a Telecaster and show you what's going on. So here we have your 2 pickups. Your 2 pickups are attached to a switch so that you can get either the neck pickup, the bridge pickup, or a mix in between them. So what the switch is going to do is route your pickup signal through this wire. Okay, so as we can see, your guitar signal is going to come through this wire. It's going to go into the potentiometer and it's going to come out through the wiper. Okay, so based on where that wiper is going to control how much resistance your guitar signal has to go through before it gets to your output jack, which is here. Okay. So the other thing I want to mention is that I kept saying that at ground, your signal or your volume is at 0 volts. Okay. Now, what exactly is ground? So most of the time for amplifier chassis, for a tube amplifier, ground is going to be a reference point, which is going to be your chassis, and on your guitar is going to be your controls, your control plate. So you can see that this black wire is connected to the back of the pot. So your pot is screwed into your control plate so that it makes contact with that metal. Okay, and it's important for your controls to be grounded because metal, okay, makes a shield against radio frequencies that you may get, noise that you get from lights. Okay, so that's why we often make ground contact with a metal surface that's going to cover our circuit because it protects from noise. So everywhere where a ground is needed in a circuit, you'll see in a guitar, it's going to connect to the back of the pot, and that's because the back of the pot is going to connect to your control plate typically, which will shield your whole circuit. Okay, so next what we're going to do is we're going to talk about the tone circuit. Okay, so as we said before, all of the black wires that require ground to get soldered to this pot shell. And solder is just metal that you can melt with a soldering iron. Once it dries and cools, then it becomes solid metal. But you can use a soldering iron to make it liquid. Okay, so next we'll talk about the tone circuit in your guitars and how capacitors help the tone circuit in your guitar to work.